Hello, geometry students. It's Mrs. Thompson. We are going to jump into section 5.8 now. And I love 5.8. I remember studying this when I was in high school. This was really fun and it's interesting to see these relationships. These are special triangles that we're going to talk about in this whole section. Section 1, example 1, is dedicated to the 45-45-90 triangle. That's a special relationship because whenever you have two of the angles that are equal, that means the sides opposite of them must also be equal. That's a really cool relationship. So we learned early on that smaller angles are going to have smaller side lengths opposite of them. Bigger angles are going to have bigger side lengths. So here's this particular theorem. You can just call it the 45-45-90 triangle theorem. You're going to put this in your electronic notebook. And it just basically shows you that two of the sides are going to have the exact same length. Those are your 45-degree angle sides, basically. The sides that are opposite of those angles. And they're in red, as you can see in the triangle, here and here. Those are the sides opposite of the 45-degree angle. Now, what's neat is this relationship. Your hypotenuse is always going to be whatever the length of your side is times the square root of 2. Okay? And I want to make sure you understand that. So if you're looking for the hypotenuse, if that's what you're trying to find, they gave you the leg and you need the hypotenuse of this particular triangle, then you're going to multiply leg by the square root of 2. That's how you do it. That's how you do it. That is, in and of itself, the simplest way I can tell it to you. Now, to reverse that, let's say you're looking for the leg, then what you would do is you would divide the hypotenuse by the square root of 2. So that reverses it. Okay, so I know a leg and I need to find the hypotenuse, then I'm going to take that leg that I know the length of and I'm going to multiply it by the square root of 2. That's my hypotenuse length. Okay, if I am looking for the leg, I've got the hypotenuse and I need to work backwards and find the original length of the leg, then I'm going to take the hypotenuse and divide it by the square root of 2. Okay, so I'm going to make sure I emphasize that. If you want to put this information here and here in your electronic notebook, feel free. I don't care. If you think, oh, I can remember that, then don't worry about it. Okay, so let's practice the math for this, and let me show you how to do this. A is really easy. I like A because they want us to find X, and in A, X is our hypotenuse. So I know that one leg, and in fact both legs, are 7. And to find my hypotenuse, I'm going to take the length of the leg, 7, times the square root of 2. And that means the hypotenuse is 7 times the square root of 2. Because they don't want a decimal answer. They want it in simplest radical form. And that's as simple as I can get it. I cannot break down the square root of 2 any more than that. So that very simply is the answer. Now let's look at B. Find the value of X. Now X, notice, this has to be a 45-45-90 triangle because I have two sides that are equal. In a right triangle, that means the angles have to be 45 degrees. So to find the original length of the leg, I'm going to take the hypotenuse and I'm going to divide it by the square root of 2. Now, I don't know if you remember from algebra or not, but you cannot, should not, do not, cannot leave a radical in the denominator. You can't. If you do, you're going to get it wrong because you're not going to see your answer, especially in a multiple choice test. And whether it's a multiple choice test or not, you can't leave the square root, any square root, in the denominator. So here's how you handle that, is multiply top and bottom by that square root. So you notice that a number divided by itself is in essence 1. So I'm basically multiplying 3 over the square root of 2. I'm multiplying it by 1 technically. And so I'm not doing anything that's incorrect mathematically. That's the point I'm trying to make. Okay, so I wanted to, the reason why I circled it was to remind you that a number divided by itself is 1. I'm really multiplying this first fraction by 1. Okay, now what I'm going to do to simplify is multiply the numerator straight across the top 3 times the square root of 2. Got it? And then across the bottom, I've got the square root of 2 times the square root of 2. Hopefully you remember from last year I said, well, the shortcut to that is it's just 2. A radical times itself is merely the number underneath the radical. So for example, if you needed to know what the square root of 10 times the square root of 10 is, that's 10. Square root of 3 times the square root of 3, that's 3. Or if you're like, I'm not going to remember that, you could go, well, what's the square root of 2 times the square root of 2? That's the square root of 4, which is a perfect square, so you can take the square root of 4 and you'll get exactly 2. And here is your answer. That is how long that side is for that leg. Okay? So if you have any questions about that, bring those to class. We'll be practicing that concept. So don't fret if you're like, I didn't quite get it today. We will practice it. Okay? Write down any questions and I'll talk to you tomorrow about it.